This is a flip video on more stoichiometry conversions. We're going to take these conversions one step further and go all the way from whatever is given to us to a final gram value. So we might be starting off with grams and going all the way to grams. And so there's going to be an extra step in these conversions. So two things to still remember that have not changed is stoichiometry is going to be still in using a balanced equation. It's still like a recipe. So we're still going to have balanced equations, whatever they may be. Two other things to remember, or other things to remember, I don't know how many things now, 3 things I guess total, is that we're still going to be using mole ratios because we're going to be changing substances, right? Like maybe we're going to be going from hydrochloric acid to carbon dioxide. That's going to change the substance. And we still have our old conversion to remember from last chapter, and that is 1 mole is still equal to the mass from the periodic table. Remember, if I'm talking about 1 mole of hydrochloric acid, I can get hydrochloric acid's mass from the periodic table. Okay, so let's remember those things. They're going to come up. Let's go ahead and start with a sample problem. Remember, we always start off with a balanced equation, and so if the equation's not balanced, you should balance it. I've balanced this one for us to begin, so make sure your equation is balanced. Again, if it is not balanced, balance it yourself. And then let's look at a sample problem here. And let's see how this differs from some of our other sample problems. So it says, how many grams of CO2 are produced if 15 grams of HCl are used? So something to right away point out is, are we changing the substance? And hopefully you said yes. We're given 15 grams of HCl, and we want to go to grams of CO2. So HCl's are given, and we want to change that substance, and we want to see what's the relationship and see how much CO2 is produced. So here is HCl. And so instead of starting off with 2 moles of HCl, we're not even starting off with moles. We're starting off with 15 grams of hydrochloric acid, HCl. And they want to know how many grams will 15 grams of HCl, how many grams of the CO2 are we going to make? So I'm changing my substance, which means that I need a mole ratio. Somewhere in this problem, a mole ratio. Now, I also know I'm going to need this because this is the only conversion that has mass in it. This is the only conversion we've ever learned that has mass in it. Okay, so let's begin. Now that we've established why this is a stoichiometry problem, and we know what we need, let's go ahead and begin. So I always begin with my given. That never changes. 15 grams of HCl. And also remember, whatever unit's up here goes down here. That's how I know what is my next step. So it's not a mole ratio yet. It's grams on the bottom. Now remember, there's no such thing as a gram to gram ratio. So what's the only conversion that has grams? Well, that's 1 mole of whatever substance is equal to its mass on the periodic table. I'm talking about hydrochloric acid. So 1 mole of HCl is equal to the mass from the periodic table. So I look up hydrogen and chlorine, and I get the molar mass of hydrogen and chlorine, and I calculate that. So just a reminder, here's a quick calculation. 1 atom of hydrogen times its mass, 1 atom of chlorine times its mass. I add them up. For sig figs, 2 places after the decimal here is the least amount, so my answer has 2 places. So that's my molar mass of hydrochloric acid. Just HCl. I don't have to worry about this coefficient. That doesn't come in until the mole to mole ratio. Okay, now I want to keep in mind my goal is I need to get to grams of CO2. And I have HCl still. Good. This top unit should cancel out with this. Don't cancel it unless it matches. Okay? Then, whatever's up here gets copied down here. So, moles of HCl. So hopefully you're saying, this all looks very familiar. We've been doing this. Now, as soon as you've got a mole here on the bottom, do a mole ratio. So I'm going to use a mole ratio to change my substance. If you remember, we're going to CO2. A mole ratio is where you change. How do I know this was a mole ratio? Well, I had a mole on the bottom. As soon as you have a mole on the bottom, put the mole on the top for the mole ratio. That's how you know. You will only use one mole ratio in a problem. And this is it. I get these from the coefficients, 2, and then in front of the CO2 is an invisible 1. Okay, that mole of HCl cancels out with a mole of HCl. Now, I'm not done because I want grams of CO2, not moles of CO2. So what do I do now? Remember, whatever unit's on the top gets copied on the bottom. And then if you also remember something good to write down, we cannot do a mole ratio again. Why? Because the rule is you only get one mole ratio. That's it. And I don't want a mole ratio because I want grams of CO2. So guess what? Remember here? We're going to use the same thing over here. 1 mole of any substance is equal to its mass from the periodic table. So I want the grams of CO2 from the periodic table. So I look up carbon's mass. And I have 2 times as many oxygen's mass. So I did a little molar mass for you. 1 atom of carbon times its mass. 2 atoms of oxygen, remember we have CO2 times its mass. And then I added them all up. 2 places after the decimal when you add. Least amount of places. So 44.01 is the molar mass. So if you noticed, up until now, we've been going to moles or grams. And now we're taking it one step further. So we have 1, 2, 3 conversion factors now. So over here I did moles in the molar mass, and over here I did moles in the molar mass. This cancels out with this. And now remember, you want to look at your given anytime you convert for sig figs, 2 sig figs. This is where you need to pull out your calculator, and you need to get an answer and put it down in your notes. So it's time for your calculator. Your answer should have 2 sig figs, and the unit should be grams of CO2. All right, on to the next problem. This is the last problem we'll do. And that problem is just like our other one, just another sample one. And for the sake of convenience, we are going to keep our same balanced equation, though you can have others if you'd like. But this one asks me about hydrochloric acid and calcium carbonate. So now they're asking how many grams of calcium carbonate are required if I use 15 grams of HCl. So I'm still using 15 grams of hydrochloric acid. But they now want to know, then if I'm going to use that much in the recipe, how much of this do I need for the recipe in grams? Okay, so same thing. I start with my given, 15 grams of HCl times. Now again, it's all going to look pretty familiar. And grams of HCl go on the bottom because tops and bottoms cancel out. What's the only conversion that has mass? 1 mole of any substance is equal to the mass on the periodic table. 1 mole of HCl. Now, if you remember, I already calculated the molar mass of HCl, so I'm just going to copy that molar mass down. Remember this? So if you've done it in a previous problem, it's kind of like a freebie. Okay? And then I'm going to keep going. Remember, the goal is how many grams of CO3 are there? CaCO3. Okay? So whatever's here on the top goes here on the bottom, moles of HCl. Again, you get 1 mole ratio in every problem. I want to change the substance. The minute your moles are on the bottom, it is time to change the substance. I want to go from HCl to the relationship of CaCO3. Where do I get these numbers? The coefficients. Moles cancel out on top, moles cancel out on bottom.